Hello everyone and welcome back to the channel. If you've been following our videos, you should be up to date with various activities and events of OpenAI. Today, we will be talking about a show of superiority displayed by OpenAI in its recent release. Yes, we would agree that OpenAI has been doing tremendously well in the history of AI, but is this show of superiority right? It has caused quite an uproar on various social media outlets with people voicing out their opinions. Some people think that Sam Altman is only reaching beyond his limit. The controversial release, which can be summarized as OpenAI, lays out principles that practically state how AI models should be structured. Was this release a suggestion or an authoritative directive? Sounds like OpenAI should govern other AIs, right? Let's work you through the release, then you draw your conclusion from it. The bombshell-like message was released via their website. Tagged, "Securing advanced AI systems will require an evolution in infrastructure security." OpenAI stated 6 security measures that are believed will complement the current security measures in place for advanced AI. You will have to agree with the fact that AI is a sought-after technology of our time. Its application to various fields, however, comes with security threats. As we have developers, we also have cyber shacks hunting vulnerable AI models. OpenAI believes that these security threats are expected to increase as AI continues to be welcomed in various fields. The defense system against these threats is just as important as the model itself. So OpenAI is posing as if they've identified all possible threats and countermeasures, and therefore are forcing it down the throat of other AI companies. The security principles proposed by OpenAI are built around safeguarding the model weights of AI models. This brings us to the question, what is model weight? You can simply say it is the brain of an AI tool. Model weights are parameters that define the structure of the decision-making logic of a machine learning model. It is the problem-solving pattern from which the machine draws data for making predictions decisions. In the training of a model, developers combine sophisticated algorithms, curated training datasets, and vast amounts of computing resources to produce sequences of numbers stored in a series of files. Therefore, AI developers must protect these files as they embody the power of the model, which could be disastrous if a hacker gets access to such files. How does this work? To power tools like ChatGPT and the OpenAI API platform, users must be able to send API requests to infrastructure, hosting the model weights. While hosting model weights enables anyone with an internet connection to harness the power of AI, it also presents a target for hackers. OpenAI, in the spirit of shared work and shared responsibility, at least that's what they claim, shared security measures for advanced AI infrastructure. These are not to eradicate current measures, but to complement previous cybersecurity protocols. So what are the principles proposed by OpenAI and why is it looking bad for open source AI? The suggested measures are built around having trusted computing for AI accelerators, network and tenant isolation guarantees, innovation in operational and physical security for data centers, AI-specific audit and compliance programs, building AI for cyber defense, as well as testing the resilience, redundancy, and research strength of an AI machine. They sound like technological jargon, right? Let's simplify what they imply. Starting with trusted computing for AI accelerators, this involves extending trusted computing primitives beyond the CPU host and into AI accelerators themselves. This has the potential of adding a new defense mechanism to AI workload. This is a new encryption security for hardware technologies, such as adding cryptographic protection at the hardware level. It could achieve benefits such as better protection. The higher security mechanism can be measured based on what the graphics processing units, GPUs, of the model can attest to. GPUs can now be authenticated and verified for integrity through cryptographic attestation. With cryptographic primitives, GPUs can keep model weights encrypted until loaded, enhancing security against host or storage breaches. So this helps prevent events similar to the Meta leak that happened before it was released. Unique cryptographic identities enable encryption of model weights and inference data for specific GPUs. This ensures that only the authentic GPUs can access models. This keeps data encrypted from the client to the designated GPUs. Now to network and tenant isolation guarantees. How does this improve the cybersecurity of AI models? Network and tenant isolation have the potential to enhance the cybersecurity of AI models by providing strong boundaries that protect AI infrastructure from deeply embedded threats. Now, we are talking about internal threats. This concept goes beyond the traditional notion of air gaps. While useful for network segmentation and protecting sensitive workloads, they are often underspecified and impractical for inherently connected systems like AI services. Instead, flexible network isolation is prioritized, enabling AI systems to operate offline and separate from untrusted networks, including the internet, thereby reducing the attack surface and potential vectors for data exfiltration. Careful design of management networks is also crucial, adhering to similar isolation principles to minimize risks. This approach recognizes that computing infrastructure needs management access, but it focuses on eliminating potential attack surfaces and data exfiltration vectors. While this type of control may not suit all use cases, such as internet-facing tools, it is particularly appropriate for protecting the most sensitive AI workloads. Up next is innovation in operational and physical security for data centers. Operations and physical security measures for AI data centers are necessary to ensure resilience against insider threats that can compromise the confidentiality, integrity, and availability of the data center and its workloads. We anticipate stringent controls spanning conventional and novel methods. Conventional methods include extensive fortification, access controls, round-the-clock monitoring, prohibitions on data-bearing devices entering and leaving facilities, data destruction requirements, and two-person rules. Moving on to AI-specific audit and compliance programs. It's only normal that AI developers think they deserve some sort of assurance that their intellectual property is protected when working with infrastructure providers. AI infrastructure should be audited for and compliant with applicable security standards. SOC 2, ISO, IEC, and NIC are existing standards. The expectation of OpenAI is AI-specific security and regulatory standards should be added to the list of security measures that address the unique challenges and fear of securing AI systems. It is important to note that OpenAI is a major part of the CSA AI Safety Initiative's Executive Committee. So in actual sense, moves like this are expected to be seen from them. So AI auditing will be done from time to verify if the model weight is authentic. Moving on, how can AI be used for cyber defense? It is believed that AI models will have the potential to level the playing field between attackers and defenders. How does this help? Defenders often struggle to identify and analyze signals needed to detect and respond to threats to their networks. The use of AI to detect potential and ongoing attempts of hackers will help defenders to combat more easily. If security automation is implemented, it will accelerate cybersecurity engineers' response to threats. This will be transformative for cyber defense. The resources required to build a sophisticated security program are significant. Therefore, cyber self-defense will not only improve its effectiveness, but will also cut costs. Finally, the sixth measure, resilience, redundancy, and research. These measures need to be tested. Although there is no perfect security, it is still important to verify these attributes. AI machines should be able to understand human intention from prompt and not assume what the intention is. AI machines should be trained not be able to alter human decisions by making suggestions. By building redundant controls, raising the bar for attackers, and building the operational muscle to interdict attacks, we can prepare to protect future AI against ever-increasing threats. These are the security protocols released by OpenAI, which seems to be a major blow to open source AI. Although there are claims by some people that OpenAI has not achieved AGI. However, these security protocols released by OpenAI seem to be pointing to the fact that artificial general intelligence has been archived internally. OpenAI may have a model that possesses the capability to understand, learn, and apply intelligence across a wide range of tasks at a human-like level. So, what do you think about OpenAI's move? Do you think it's a genuine step for cybersecurity? Is Sam Altman overreaching? Share your thoughts in the comments. That wraps up this episode. Don't forget to like and subscribe for more videos. You won't want to miss the latest updates as they come out. Things are heating up among AI companies like Microsoft, Google, and of course, the controversial OpenAI. And we are here for the drama. Thanks for watching, and see you in the next video.